Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Now we are going to see in this video about the nanotechnology in nanomaterials. So, nanotechnology is an emerging field in the current scenario. It has application in a very wide range. In this, we are going to see about the definition, history, classification, the timeline of the different nanotechnology, comparison of the nanomaterials with that of the bulk materials and applications. So, while introducing the nanomaterials are the materials which has the size in the range of 1 nanometer scale to 100 nanometer in scale. The nanotechnology is the study of the manipulating matter on an atomic scale. It also refers to the constructing and engineering of the functional system at very micro level or at the atomic level. A nanometer is one billionth of a meter, that is 10 to the power of minus 9. It's roughly the width of 3 or 4 atoms. The average human hair is about 25,000 nanometers wide. So we can see in this picture a carbon nanotube and fullerene molecules, which is C60. Nanostructure materials are the materials with a microstructure, the characteristics length scale of which is in the order of a few nanometers, that is typically from 1 to 10 nanometers. The first ever concept was presented about the nanotechnology in 1959 by the famous professor of physics, Dr. Richard P. Feynman. Invention of the scanning tunneling microscope in 1981 and also the discovery of the fullerene, that is the C60, which we saw in the previous slide, in 1985 led to the emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. The early 2000s also saw the beginning of the commercial applications of nanotechnology, although these were limited to the bulk applications of nanomaterials. For instance, silver nano platform, it was used for silver nanoparticles as an antibacterial agent. Then nanoparticles based transparent sunscreens were also used, and the carbon nanotubes were used for the stain resistance textiles. So, when you do a comparative study of the macro, micro, and the nano scale, in the macro scale range, when you compare a person of a 6 feet tall, he's 2 billion nanometer scale. So, for an apple and for an ant, it is about 80 million nanometer and 5 million nanometer, respectively. The micro scale range, that is the diameter of the human hair, is about 75,000 nanometer, and the smallest the eye can see is 10,000 nanometer. So an E. coli bacteria is about 2000 nanometer. Then the nano range scale, it's the buckyball, it is in 1 nanometer range, and the DNA strand, it is of 2 nanometer range, and a carbon nanotube, it's about 1.3 nanometer scale range. So when we see the timeline of the nanomaterials, it's the first generation products. It's before, that is up to 2000. They are the passive nanostructures materials like aerosols, colloids, coatings, nanoparticle reinforced composites, nanostructure metals, etc. For the second generations, they are the active nanostructures like bioactive, targeted drugs, biodevices, 3D transistors, etc. And up to 2010, it is third generation products, that is guided assembling, 3D networking, and new hierarchical architectures, robotics, etc. And from 2015 to 2020, it's the fourth generation. You have the molecular nanosystems, example, molecular devices by design, atomic design, emerging functions, etc. So we are interested to see about the classification of the nanomaterials. There are many types of classification. In this video, we're going to see about the classification based on the dimension. So there are different dimension, four types. There are the zero dimensional, one dimensional, two dimensional, and three dimensional.